Okay, so as I said before, a unit vector is a vector with length of 1. So we are going to be, oh boy, just a little bit off. That's not the worst. What I want to do is move that down a little bit. Okay. So a unit vector is a vector with length 1. Here's how you transform it to a unit vector. So you take the vector and you divide it by the magnitude. Okay, so to change a unit vector to a vector of length 1, you divide it by the magnitude. Okay, vectors I and j. And like I said, this is just like transforming a complex number in rectangular form to polar form. Okay, it's the same idea. So vectors I and j. The I vector is equal to 1, 0. The j vector is 0, 1. A vector can be written as a linear combination of I and j. So it has a horizontal part, an I part, and a vertical part, a j part. And the way in which we do that is we take the vector AB. We think of it as just its horizontal part, which we call A0, plus just its vertical part, which we call 0B. Factor out an A, so you have A times 1, 0, which is the I part, plus B, factor out a B, pull a B out of the second part of that, and it's thought of as B times 0, 1, which is the J part. So the vector can be written as AI plus BJ. So we're just going to do a couple examples for you. That 4 of these is too many, 1 through 4, but we'll do a couple examples here from 1 through 4. I'm going to do one where it's not one that's on the unit circle, and then one where it is. Okay. So we'll do number 1 and number 3. Let's do number 1 and number 3. So it says for the given vector, find a vector in the same direction with unit length. So to transform this to have unit length, we need to do what it says up here. Take the vector and divide it by the magnitude of the vector. Now, how do I find the magnitude of this vector? Remember, this is my A part right here, and this is my B. So it's just the magnitude, V, the vector V, equals the square root of 5 squared plus 12 squared. Some of you may even recognize this is a Pythagorean triple, 5, 12, and 13. Yep. So if you recognize that, perfect. Okay. Like I said, lots of connections to trig and special right triangles here. Okay. So don't get too caught up in the vector form. It's a lot of what we've done before. So in order to transform this vector into a unit vector, all we do is take the 13 and divide it into the A part and the B part. And so there is my unit vector. I'll box it right there. Okay, so you find the magnitude. And you divide the A and the B parts by the magnitude. So, if I use the Pythagorean theorem on my unit vector, what value would I get for the hypotenuse C? 1. If I square 5/13 and I square 12/13 and I add them up, take the square root, I should get 1. That's what I've done, is I forced this to be on the unit circle. Okay, we are 5/13 over, 12/13 up. If you square each of those numbers, add them up, take the square root, you'll get 1. Now, where that's really nice is when I can get values that are at a special right triangle angle, okay, like a 30, 45, or 60. For example, number 3. What is the magnitude on number 3? We'd have square root of negative 2 squared plus negative 2 squared, which is 4 plus 4 is 8, square root of 8. Or simplified, it would be 2 root 2. And so if I divide each of those terms, and I'm going to spill into this, we're just going to do 1 and 3, and that's it. It would look like this. Negative 2 divided by 2 root 2, comma, negative 2 divided by 2 root 2. May not be recognizable yet, but if I rationalize the denominator by multiplying by root 2 over root 2 in each case, look like this. Let's just do our scratch work over here. Negative 2 over 2 root 2 times root 2 over root 2. What does that equal? Yes, let's break it down a little bit here. We have negative 2 root 2 over 2 times 2, which is 4, and so I get negative root 2 over 2. So, in fact, both of these are negative root 2 over 2, comma, negative root 2 over 2. Could you then, let's go ahead and box that, could you then tell me the angle I'm at for this unit vector? In degrees? 135, yeah. I am in the second quadrant. I'm the same left as I am up. I'm negative root 2 over 2. Sorry, I went the wrong way. So 225, you're correct, not 135. Negative 2 root 2 left, negative root 2 over 2 left, and negative root 2 over 2 down is 225, yeah. So then you have an angle to go with it. So if your unit vector is one that places you at a special right triangle angle, you can easily get the direction as well to go with the magnitude. Now the magnitude on all these is 1. We just transformed that vector and placed it on the unit circle. So just a couple examples. We're going to leave it at that. Just doing 1 and 3. All right. Next one that says sketch each vector and find its magnitude. So we're going to sketch the vector and find its magnitude. Let's just choose what looks like the most difficult one here, number 6, and we're just going to do that one. So 5/3 I plus 5 root 3 over 3 j. So the I is going to be the horizontal. If you want to label it here, this would be I, and this would be j. The vertical is the j. So 5/3 I'm just going to approximate about where this vector would be, and then we'll go ahead and find the magnitude. So 5/3 I would be 1 2/3, so somewhere between 1 and 2 here. I'm going to go over that far. And then 5 root 3 over 3. If I were to estimate that, what's root 3 equal to? About 1.7. So 5 times 1.7 is 5 plus 3.5, which is 8.5. 8.5 divided by 3, 2.8-ish. So just below 3 up. So I'm going to go about almost 2 over and almost 3 up, and just put a dot there. And if you'd like to, you could label the sides. That connects it to a right triangle mathematics here. We've got 5/3 is one leg of that right triangle, and the other leg is 5 root 3 over 3. There's my right triangle. And so when I'm asked to find the magnitude, all I'm doing here all that I'm doing is using the Pythagorean theorem. So it looks like this. Got square root of 5/3 squared plus 5 root 3 over 3 squared. So I'm squaring each of the legs of that right triangle. And that equals square root of 25/9 plus 5 squared is 25 times root 3 squared is 3. 25 times 3 is 75 over 3 squared is 9. So I've got 75 over 9. Comes out fairly nicely here. Square root of 100 over 9. Both are perfect squares. So I get 10/3. And that is my magnitude. So here we have a magnitude V of 10/3. That's just telling me the length of that vector. So magnitude V is equal to 10/3. So that's sketching the vector and finding its magnitude. The only reason I'm having you sketch it is so you can see that connection between this and right triangle mathematics or trigonometry. Down below, we have given V equals 5i plus 4j. So that's a vector written in its component form here. Or magnitude direction form here. And then it says, and W equals 3i minus 9j. Find the following vectors. So we have these vectors broken out so that they're written in, kind of given their horizontal part and their vertical part. So they're given in that form. And then we're asked to go ahead and do some, what we call linear combination of these. So we're going to just do a couple of these. Find the new vector. This is what we did last time, adding and subtracting vectors. They're just in a different form. Instead of in that A comma B form, they're in the I plus J form. So let's do maybe number 9 and 10. 8 and 11 are just acting on one of the vectors. Like 6v would just be 30i plus 24j done. Okay? You just multiply 6 by each of these. Or over here on 11, negative 1/3 w, you'd go negative 1/3 of this would be negative 1i. Negative 1/3 times negative 9 would be positive 3j, and you'd be done. These are actually combining these two and also multiplying by a scalar. So negative v plus w would look like this. Negative v would be negative 5i minus 4j plus w is just 3i minus 9j. And then we combine them and we get negative, it's just like combining like terms, negative 2i minus 13j. Or, oops, that should be a j. Or another way to write this in the form we had last time is negative 2 comma negative 13. All right, and then number 10. 4v. 4v is just multiplying 4 times v. So it'd be 20i plus 16j minus negative 2 times this would be minus 6i. Negative 2 times negative 9 would be positive 18j. And then you just treat these as though they're variables and you're combining like terms. And you get 14i plus 34j, or 14 comma 34. It is too easy. But it connects to stuff we've done before. Okay, there's nothing real new here. It's just new notation. That's about it. So any questions on any of these? This is what we were doing. This is what you were doing last time, okay, in the homework. Just you were doing it in this form here rather than the I and J form. All right, vectors in magnitude direction form. So this is the connection to the polar form of a complex number when we did it in that was let's see, 2 chapters ago. So showing it there, okay. So we have some formulas here. We've got cosine of theta is equal to, I've got to calibrate this just a minute here. This thing is not cooperating. So cosine of theta, let's try it again here. So we got cosine theta equals, looking at the picture over here, if I make a right triangle out of this, cosine of theta, there's my right angle. This would be A, this would be B, so cosine of theta would be adjacent, right, over hypotenuse. If I call the hypotenuse the magnitude of V instead of C or R, then I have adjacent A over magnitude V. And if I wanted to solve for A, it would look like this. A is equal to the magnitude V times cosine of theta. And I can do the same thing with sine of theta. Sine of theta is equal to opposite B over magnitude of V. So B is equal to magnitude of V sine of theta. And so those are my formulas that will change these vectors into magnitude direction form. All I have to know is the magnitude of V and the angle theta. So we're going to find the magnitude of V and the angle theta. So go down to, let's pick one of these to do. How about, actually we'll do two different ones. Let's do 12 and then also 13. So we'll do one that's not at a 45. So 12, we've got 3 and 4. How would I get the magnitude of this? We could even draw a picture if you want. But we're 4 up, 3 over. Do you recognize this guy? 3, 4, 5, yes. So the magnitude V is equal to 5. The magnitude V is equal to 5. Now, do you recognize this in terms of an angle theta? Probably not, right? Probably not. We don't. If I think of it this way, it's just inverse tangent of opposite 4 over adjacent 3. That will give me theta. 4 over 3 is not one we recognize. It's not a special right triangle angle, so you shouldn't recognize it. So in this case, on our calculator, in degree mode, we would type in inverse tangent of 4 over 3. I need your help on this. And then we're ready to change it over into magnitude direction form. I'm going to go back up to these formulas here. We're going to put that all together. Here's my A, here's my B. Theta is equal to, can you get it to the nearest? Tenth would be appropriate, I think. It's probably good enough. What is it? 53. Thank you. 53.1 degrees. So this one is not on the unit circle. So up here, going back up here, I got a little bit ahead of myself here. It should be AI plus BJ. There's I plus J form. This becomes norm of V, or magnitude of V, cosine of theta I plus magnitude of V sine of theta J. So this is the form we're trying to change this vector into. And so now it's just a matter of plugging in. Okay. So that's the form we're trying to get it into. Let's go ahead and do that down here. So magnitude of V is 5. So I've got 5 cosine of 53.1 degrees I plus 5 sine of 53.1 degrees J. And that is magnitude direction form. It has both the magnitude attached to it, that's the 5, and a direction, 53.1 degrees. On a lot of the problems I'm going to give you for practice, I'm going to stick to the unit circle. So both 13 and 14, you could probably tell me, what's the angle here? It's the same as the one before, I think. Negative 5, so what am I? Yeah, 225 again, yeah, 225, or negative 135 if you wanted to. It doesn't matter. But in terms of degrees, yeah, that's it. So 225 degrees, then you'd find the magnitude. Let's look at 13 just because it's something other than a 45-degree reference angle. So drawing a quick little sketch here, I'm up over here. So I've gone 6 left, there's a right angle, 6 root 3 up. So my magnitude is equal to square root of 6 squared plus 6 root 3 squared. So magnitude is 36 plus 36 times 3, 90 plus 18 is 108. 36 plus 108 is 144, so I get 12. So the magnitude of V is equal to 12. It's a 30-60 right triangle, so it makes sense. I would double the shortest side to get the magnitude or the hypotenuse of that special right triangle. So 12 makes sense. So that's the magnitude. Can you tell me the angle? I'm up high over here. Angle in degrees. Here's 90. I'm going to add another what to it? Yep, add another 30 to the 90, so it's 120 degrees, yeah. Because we are farther up than we are out. Okay, so it's a 60-degree reference angle here, or 30 degrees to the left of that 90. So 120 degrees is my theta. So theta equals 120 degrees. And so my form is 12 cosine 120 degrees in the I direction. And what should the sign on this be here? Oh, we've got it taken care of. So plus 12 sine of 120 degrees in the J direction. Here's what I mean by the sign is taken care of. Cosine of 120 degrees would be a negative number, right? Cosine of 120 degrees would be negative 1/2. And negative 1/2 times 12 would get me back to negative 6. Sine of 120 degrees would be root 3 over 2. And root 3 over 2 times 12 would get me back to 6 root 3. Okay, so this is just another way. This is magnitude and direction form because I have the magnitude and a degree measure direction to go with this vector. Yeah. 120 based on where I am on the unit circle. So this is 90 degrees here because I'm only 6 left and 6 root 3 up. I know that this angle right down here is a 60-degree angle, if you will. So I'm only 30 degrees off of that vertical line. Higher up than I am out. So that's it. I think on a lot of these that I give you, there'll be some where you have to use inverse tangent of B over A. Most of them will be special right triangle angles, okay? Just because I think it's good to practice that some more. All right, 15 through 17. All that we're doing, we'll just maybe choose, once again, 2 of these. One that's a special right triangle one, and one that is not. So it says find the component form of the vector v whose magnitude and direction are given. So component form means changing it back to this form right here. Okay, so we went from here to here, from component form to magnitude direction form. Now we're going to go magnitude direction form back. So we're given a magnitude and a direction. We're going to plug it in. It looks like this. 20 cosine of 120 degrees I plus 20 sine of 120 degrees J. And then we're going to use do the same thing we did back in the polar chapter. Cosine of 120 is negative 1/2, right? Cosine of 120 gives me the coordinate negative 1/2 I plus 20 times sine of 120 is root 3 over 2. Okay. So 20 times negative 1/2 is negative 10 I plus 20 times root 3 over 2 is 10 root 3 j. And then we're not quite in component form, we're in ij form. So component form will be negative 10 comma 10 root 3. So once again, if it is a special angle, a multiple of 30 or a multiple of 45, then we can get the exact form. If it's not a special angle, like what we see in 16 or 17, we're going to have to use our calculators, okay, and then round off. So taking 17 as an example, this would be 10 cosine of 250 degrees. That's in the I direction, plus 10 sine of 250 degrees. That's in the J direction. So I'll need a little bit of calculator help. What's cosine of 250 degrees according to the calculator? Negative 0.342. Okay. Yeah, and actually to the nearest thousandth is perfect. That's good. And then that's in the I direction, plus 10 times, what's sine of 250? 40, okay, and the j. And then when we're multiplying by 10, we just move the decimal over 1. So this is negative 3.42i minus 9.40j, or in component form, negative 3.42 comma negative 9.40. So we're just using our calculator to get decimal approximations to the nearest thousandth, was perfect. Just because that's on the AP Calculus exam, that's what they want you to round to, so we'll go with that. And then go ahead and multiply it by the magnitude. So that's going the other direction, changing it from magnitude direction form to component form. Any questions on that? No? We'll go down here, maybe do one more here. It says the magnitudes and directions of two vectors, v and w, are given. Find the magnitude and direction of their sum, v plus w. I'll pick one to do here. These two. Yeah, let's just do 19. So it says find the magnitude and direction of their sum, v plus w. Sketch the vectors and their geometric sum. Okay. So we'll go ahead and do that. So draw an XY grid. And I'll do this in kind of a generic form here, but we've got v equal to 8, theta equal to 65 degrees. So v equal to 8, theta equal to 65. So if I were to just sketch this, a length of 8, we'll go maybe in blue here, at an angle of 65 degrees up, so length of 8, 65 degrees. So that's, I'm just estimating it, okay? 65 degrees up, it's less than 90. And then W is not quite as long, and it's at an angle of only 18 degrees. So W would be here. So a length of 5, and then a degree measure of 18 degrees. Okay, once again, this in here is 65 degrees. So we're just drawing a rough sketch. So to add these two, what am I going to do with this red vector here? That's a length of 5, 18 degrees up from the horizontal, you remember? I'm going to add it. I'm going to take this vector and move it to where? I'm just going to slide over. If I slide it right now, it won't work because I did like 3 or 4 different lines there. But I'm going to go ahead and do what you're going to do and just redraw it on here. Just trying to keep it parallel and about the same length, okay? So this is vector W in red, and vector V is in blue here. And all I want you to do is draw just a rough sketch. Okay, the ultimate goal is to get the new vector v plus w and its magnitude. Okay, that's the goal. So my new vector v plus w, I'll draw it in green here, will go from here all the way to here. That is v plus w. So the question is, what is the magnitude of v plus w, and also what is the degree measure theta of v plus w? So a couple different ways you can do that. If you know v and w, you can find v plus w by just adding each of those. So we're going to go ahead and do that. All right, so v, how do we get v? Let's see here. We've got 8 cosine of 65 degrees I. You see where I'm getting that from? Magnitude and direction, plus 8 sine 65 degrees j. And that will give me, and we could just do it in component form if you'd like. What's 8 times cosine of 65? You can actually type that in your calculator all in one swoop. So you do 8 cosine of 65 and give me the decimal. The nearest maybe hundredth would be appropriate. 3.38. 3.38, okay. A little more room here. Okay, 3.38 is correct. That's what I got too. 3.38, comma, and what's the next one? 8 sine of 65. 7.25, good. And then we're going to do our next vector in red there. That was the 5 cosine 18 degrees I plus 5 sine 18 degrees j. And I've got another component. I think this is probably the easiest way to do it, is get your v vector in magnitude direction form and then change it to component form. Do the same thing with the other vector. So 5 cosine of 18 is, should be 4.76. And then the other one is, other piece is, I should say, 1.55. You're just typing in your calculator. And then v plus w, which we have in green, we can now find, it's just putting a line underneath these two and adding them, literally adding them. So 3.38 plus 4.76 ends up being 8.14. And 7.25 plus 1.55 is 8.80. So there's my new vector v plus w. I've just added them together. And so if I want to find the magnitude, v plus w is going to be equal to the square root of 8.14 squared plus 8.80 squared, which comes out pretty close to 12. I should use squiggly equals so we don't think it's exactly 12, but about 12.00. And then theta is equal to inverse tangent of the b component divided by the a component. I'll use squiggly equals here as well. And so theta equals inverse tangent of 8.80 over 8.14, and I got about 47.23 degrees. So we found the magnitude, that was about 12. We found the direction, and we've drawn a sketch of the vectors and their geometric sum. Any questions on that?